Okay, I think it's time. All right, so hello everyone. Thanks for coming to my talk. Small but dedicated crowd. Um, so let's start with who I am. I'm Mehmet Ali, or Mali for short. I've been at Hubspot for about 4 years. I've been working as a data infrastructure engineer, and I've been working on our internal database as a service, in quotes. I'll explain a little bit more about that. Originally from Istanbul, Turkey. And here's our marketing slide. I'll talk for a moment about what the company does because it'll, I think, lead in nicely to what I'm going to talk about today. So HubSpot's just a CRM plus marketing plus sales plus content management plus customer service plus a bunch more things all in one. So the idea is that, like, if you run a small or medium business, you probably could use one or any of our things. And it's all crafted from scratch to work well together. The reason that I'm telling you about this is because we're really a lot of products under the umbrella of one single big product, right? So it's like we're running many little companies, if that makes sense. So a little bit about like HubSpot SQL infrastructure today. We run about 10,000 MySQL instances. That includes like all of our regions and also QA. My rule is like if it breaks and I have to fix it, then it counts, I think. We have about 1,500 product engineers who are running tens of thousands of microservices, like they're really microservices. We do a lot of database migrations. We do maybe like about 1 million queries per second peak during like sort of midday, mostly on the primaries, and then the replicas do a little bit more. And it's only 12 of us who have to deal with all this stuff, right? So there's no sysadmins, there's no DBAs. It's just like 12 database engineers versus 1,500 product engineers. We're software as a service, so planned downtime is extremely rare or never done at all. And like what we do as a small team is like all the stuff that Percono and other companies are like, we're never building that. No one wants this. That's too niche. That's the stuff that we end up building on top of what's already like available publicly. And we do all this stuff because we want the best developer experience for all of our developers, because we want them to be able to like build stuff in the most uninhibited way possible. And we never want to be the roadblock between like a feature actually happening and a developer. So sometimes this means like last mile delivery. We're like wrapping and integrating existing software and just kind of making it work a little bit more nicely with our ecosystem. And a lot of times it's also like just inventing new stuff out of whole cloth. I said all this stuff already. Okay, so what's this talk about, right? So 1 million queries per second, I mean, it's like a lot in some context, but it's really like not that much, because if I think like in 2018, someone was able to run 1 million queries per second on like one single commodity gigantic server, right? Maybe not commodity. But so our challenge is a lot less like Formula One and a lot more like sort of bumper cars, where like, it's like we're not really worried about like tuning to the nth level, like really carefully all these key spaces. We take sort of like the exact opposite approach, right? So we don't believe in special servers. Like the largest server we have probably has 100 gigs of RAM, and that's like an extreme outlier. Like I think 40 or 50 would be large for us. That doesn't mean that the data isn't big. It's that we're able to sort of like break things down in such a way because of all the sharding and all the stuff that we use, which I'll talk about in a second. So no bare metal, no dedicated stuff, just a really, really sort of cheapest possible hardware and storage, like all bin packed and containerized into all on some Kubernetes nodes. So code word there being like cheap and simple. We also have like the bumper cars aspect of it comes from the fact that we have like a massive number of different workload types and different services, and a lot of variation among teams, like in terms of like experience levels with like SQL stuff, with databases, with schema design, best practices. All the stuff can vary greatly, right? We have a lot of engineers who are very young, like not in terms of age, but like have just graduated maybe, or just starting their career in engineering. And this is just the thing that happens in every company that you have to like figure out a way to deal with. So So it's a little bit like being as a database as a service, but we also have to care about what goes on the inside too. Like if Oracle or Amazon or one of these things, like they'll happily sell you some servers and you can go nuts inside and they don't really care, right? But we have to both manage the mechanisms and also when stuff breaks on the inside, we also have to worry about that. So the question is like, how do we tame all that chaos, right? Like, but keep the developer experience like still sort of non-restrictive. Like we can still let them do whatever they need to do. Okay, so what this is not about, like this is not about the specific infrastructure and software we use, like it's more about the methodology, like that stuff. Jean-Francois did a talk about that like basically just an hour ago, so I think there'll be a recording and everything. This is also not like a declaration that this is the only way and everyone should do this, right? Or that we're doing everything spectacularly and everyone pay attention to us, right? It's just that like this is a sort of slightly different way than what we've seen, and it really works. And so maybe like some of this might be interesting to other people too. So this is a bit of a warts and all talk, right? And I'll be a little bit provocative on purpose. I'm not a zealot, I promise. Okay, so what we'll cover sort of where we started out, like, what didn't work or like kind of sort of worked, and the sort of evolution of like how we were thinking about things. And we'll talk a little bit about like what did actually really work that was maybe a little bit surprising. And then we'll also, maybe not the fourth thing, that kind of interspersed all across the middle is like sort of what SQL at HubSpot feels like. So there'll be a lot of screenshots and demonstrations and how everything works if you were a developer. Okay, so where we started. So in 2018, we had sort of legacy, right? This was pretty standard. We had MySQL with Puppet. We deployed it on Singularity, on Mesos, and we used Ansible to like do all the deployment stuff. And then we moved sort of to a new setup, and there's like a whole story about that, which I won't necessarily get into. But where we ended up was we were running Vitess on top of Kubernetes. So we had this sort of like kind of flexible, elastic sort of infrastructure, I guess, where we could sort of like move stuff around fairly easily. So a lot of what we did in those first years was sort of like getting the basics under control, right? So the first thing that we really, really wanted was sort of this full layer separation. Like you have the Kubernetes sort of hardware, quote unquote hardware, infrastructure layer. And then on top of this, you have like Vitess and MySQL. And on top of this, you have like the apps and stuff sitting. And we wanted all those things to not necessarily have to care about each other at all, right? So without the database users, whenever I say users, I mean like our developers are my users. So whenever our users, like without the database users knowing or caring, like without any downtime, we wanted to be able to sort of deal with like, maybe we need to do a Kubernetes upgrade. All that stuff happens without anything on the top not being affected, right? Database software, right? We need to upgrade MySQL, we need to upgrade Vitess. We want to be able to do this stuff without doing the thing where it's like, oh yeah, it's Sunday, blah, 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 we're gonna have planned downtime. So we have sort of like set this mechanism up where we have like rolling restarts and canary deploys and all this stuff. We do some stuff where we do like warming reads on replicas so the buffer pools are nice and warm, so we ever have to fail over, they're like already ready to take queries at the same level of performance as the primaries. So we have all this like sort of nice stuff. And then like sort of failure mitigation, right? So we have failover via orchestrator, we have some sort of chaos tests of like trying to break things and make sure that they get automatically fixed the way that they should. We have stuff to mitigate AZ outages, so like spread replicas and primaries across correctly. So if one AZ goes down, only a third of the databases have an outage. And so all this stuff like that we had to chip away for a while. So we got most of the stuff under control. And as all the old issues went away, the new ones sort of started replacing them. So hands up if you've ever noticed this. The chillest on-call period ever is the company week off. And so this is like a sort of an accidental natural experiment where you're like, okay, what if I remove one aspect of what's going on here and does everything remain the same? So the observation that we had was like that the majority of crit sits or whatever outages, problems, whatever you want to call them, were related to like the usage of the database and not necessarily about the infrastructure. So it wasn't stuff like, disk running out, or EC2 instance impaired, or network hiccups, or stuff like this, we're sort of able to get a handle on that the infrastructure would deal with on its own. But it was really stuff relating to workload and usage, right? So it would be like, there's a bad query that wreaks havoc, that takes down the entire server, or at least makes things slow enough that the user starts seeing trouble, right? Like jobs or workers are backlogged, they're getting backlogged increasingly, and if they get backlogged enough, then we're going to start losing data. Like there's timeouts and they're sort of unexplained, and the app developers are like running around trying to figure out why these are happening, and they don't know and we don't know. Yeah, like new feature gets ungated, takes the entire database down. This happens. It's like, oh, we were doing the canary and it was only 5% of users and everything was fine, and we didn't notice that we had terribly slow queries, and then it's like, boom, 100%, everything's exploding. And then there's like the sort of final where it's like sort of slow trickling growth where it's like, oh, everything's fine, and then like, boom, everything's terrible because, oh, your data set is now just slightly bigger than your buffer pool, and now your queries are like your tail latencies are a lot worse than they used to be. So this type of thing started happening a lot more often, or maybe we started noticing these a lot more often because the bigger stuff was like gone. So commonality is like sort of not infra failures. So one way to react to this is basically say like, okay, everyone stop, no new queries, no new schemas, all schemas go through us. We have to approve everything. You write new queries, we got to approve those queries. We're going to make sure that there's index in all of these. But we didn't really want to take the autonomy away from developers and create this like centralized bottleneck. And we also wanted to sort of try this thing where we teach people to help themselves. It's like the give someone a fish, teach them to fish, like that type of thing. So here's the first thing that didn't work, which is not our problem, which we tried. Turning a blind eye, right? So it's like, this is not us, right? It's not an infra problem, right? Make your queries better. Why are you not have an index? That's ridiculous, right? Like all this stuff, which I think is a reasonable reaction. But like there's sort of a valid question about like sort of who owns this problem space, right? So you have like a database team and a product team, and they're like both good at like different things, right? So there's database people have expertise in finding like the root cause workload query problem that's going on, for example. But we don't necessarily know, right? Like I don't know if like this app that's doing a lot of queries, is it supposed to be doing a lot of queries, or is it just something weird's going on? Your caching is broken or something like that. Like I can't respond to an incident if I don't know that stuff. And the product team, right, they know the thing that they're building very, very well. They know that they shipped a feature last week that does X, Y, Z, but they don't necessarily have experience sort of like doing the needle in the haystack kind of thing. And they don't necessarily, they're worried about building stuff, right? They're not necessarily pulling up their database charts every day and looking, I'll see if my like queries grew last week, right? Like they don't really do that. So this is like this weird area of like unclear responsibilities and sort of like shared responsibility, and so here's our postmortem on this. Like basically, handing off full responsibility with zero support structure, that didn't really work, right? Like a charitable way of putting this is like, that's interesting, but we don't, as a database team, have the resources to be able to deal with every single product team at the company, because that's just like, that doesn't work, right? And but the cons of this was that like if there's no support structure, like users are going to make mistakes, because that's just like human nature. That's what people do. And I had a boss who said this a lot, where it's like, it's not my fault, but it is my problem. And this happened a lot, where it's like, problems start small, but then they silently grow into larger and larger problems until like things finally blow up. And then at that point, when things blow up, it's like maybe not that easy to fix anymore, right? Maybe you can't scale the database up even further. Maybe you can't, you can't kill the queries that are causing the problem, because there's I don't know, those are real user queries that actually deserve to go through the server too. Like ultimately, people are going to look to you as the expert for like sort of systemic solutions. Like especially if you're an organization that truly does like 5 whys, or like how do we make sure that this problem doesn't happen again? People are going to be asking you about it, right? So this a little bit kind of worked, right? So the next thing that comes up is like, well, people should follow best practices, right? Or why don't they read the MySQL manual? So unfortunately, like go read this whole book is not very realistic. Like generally people are busy. I mean, I wish this worked, but I don't know, like these are my sort of explanations. I don't know that anyone's told me these, but I feel like maybe it's like, combination of like busyness, incentives, right? Like it's like you don't get a benefit immediately out of learning so much about like indexes and queries in SQL until you have a problem, and then there's like massive benefit, right? But there are some recent advancements, right? So like efficient MySQL performance, I think the guy who wrote that had a talk. Use the index loop. Like these are sort of like aimed at developers to make things easy and sort of like applicable information, I think, for those roles. But ultimately, even people who read those things are already interested, right? And those aren't necessarily the people who are writing all the queries and doing all the weird stuff with their schemas that are causing all the problems that you have. So internal documentation can be a little bit better. We'll talk a little bit more about this. It's a little bit more tailored maybe. But anyway, like this whole thing can turn quickly into a form of like not my problem. Or, like at least like it's not necessarily, we say that this is the thing that should happen, but it doesn't necessarily happen, so my life still sucks anyway. So here's when I think best practices work best, right? This is not a real framework, I made this up. But it's like, one thing that needs to happen is like awareness, right? People should know that, okay, I should be doing X, Y, Z. I should be adding indexes to all my queries. I should be doing this thing, right? If you don't know about it, then then you're probably not going to be able to do it. So there needs to be something that's like saying, hey, you're missing a thing, maybe you should be doing this thing. And that doesn't need to be me, because I don't have the patience to do that for like, I don't know, 1,500 developers, right? The other one's sort of like ability and means, right? So maybe they know that they should be doing something, but there isn't the tools required necessary to be able to like do that thing. And then there's like sort of incentives or priorities, right? Like, so sometimes there's this like notion of, well, no one gets promoted because they're improving bad code, right? And this is sort of like a toxic thing that happens in organizations. I don't have a great answer to how to fix this, but this is a thing that happens. And human beings are driven by incentives, and that's just how it goes. So documentation. We wrote a bunch of documentation. Our documentation is a mess, I think, along with basically every other organization in the world. But it does do some good things, right? It prevents repeat questions of a factual nature, right? So how do I do X? Or what is X? Or how do what happens if I Y, right? Like this type of thing, it's, I think, pretty good at, right? And you can kind of like build it up based on the questions and support stuff that you're getting, right? But it's tailored to your internal infrastructure, which is great. Like people will be randomly Googling stuff, and it's like, oh, it doesn't work that way in our company because we changed the way that blah, blah, blah works. So it's a nice thing, but it doesn't necessarily work that well for conceptual questions, right? Like it's like, oh, I want to know about like, I don't know, transaction isolation and database locking because my queries are like always failing because of deadlocks, right? So what do I do about that? Well, like A, who's going to write a documentation on that? B, like it's not, the documentation for that is going to be pages and pages long, right? So that's sort of work intensive, difficult. And people forget to link to it. This is mostly me, where I'll just be re-answering a question over and over, even though there's documentation for it. I don't know how to, we had a support bot that like did keyword matches where you were like, replication lag. And it was like, replication lag? Here's the documentation on replication lag. And that worked pretty well. But anyway, it also goes stale over time. So if you could dedicate resource for this could be great. Like I wish I had like a day every 2 weeks to just do documentation, which sounds crazy, but I feel like I could get it to be so good if that was the case. And I feel like I have no excuse to do that right now, and I really wish I did. The other thing that we kind of wanted to do was like a SQL 201 onboarding, right? It's like people always know the basics of how to get things working, but this is like you've sort of existed in the organization for a while and you know how the basics work. Now it's like we're going to teach you how to do the complicated stuff, right? And we're going to teach you how to do everything the way that we wish you would actually be doing it. So one thing that had like worked surprisingly well was doing internal tech talks. We did a bunch of these, and it wasn't necessarily in an organized fashion, but we kind of like threw them together, and we were like, Vitesse movie night, you can go and watch a bunch of these together with your teammates. And it's questionable whether that actually happened. However, when I look at the stats on these, there's a lot of like hundreds of hours of people actually watching these videos, so maybe something did actually work. So we have an internal tech talk every Wednesday, an internal conference called Epic Week, and these are sort of interesting because, okay. Yeah, so there was this one where I talked about how like the 1800 like British scientist John Snow using sort of early data visualization to prove that cholera was coming from a specific water pump is actually fairly similar to diagnosing database problems by looking at charts. I'm not going to explain that. My colleague decided that he was going to do like a game show about like MySQL locking and how this works, and I think that one says, can we call a friend? But it was like, okay, questions of different queries. And it's like, will this one block and this other one? And then a lot of people actually came out like, the people who we wanted to watch this did watch this, and then they did fix their apps, which was like, was surprising. Like we thought that we were doing something funny, but it turned out to be something that was maybe actually useful. Okay, here's the one where I was raving about like how many techniques used in storage engines today were actually invented by ancient librarians in the Library of Alexandria, which is actually factually correct. They invented like library stuff that we use today. But anyway, so like postmortem on this, like these have much wider reach is one reason why they're so good, right? Like people aren't necessarily going to pull up and look at documentation, but they are going to go to the Tech Talk every Wednesday, right? So you're going to catch that audience that you really actually want to reach, which are the people who aren't really looking at your documentation. So that's like one really good reason to be doing this. And if you make it engaging, people actually do sit and listen to something that they otherwise maybe wouldn't have. Like who's going to read? I mean, I don't know, I sometimes read that, but who else is going to read, you know, like, I don't know, a bunch of pages on something that's very arcane. Cons is, yeah, I mean, it's a huge pain in the butt, honestly, to be realistic. So it's okay ROI if you do it once or twice a year to a large audience. Okay, so one thing that we do though, in terms of awareness is linting, but we don't like throw the set of default lint rules to like everyone. What we try to do is to be sort of like very careful about the things that we're throwing into lint rules, right? So we want things where we really want to, like we're trying to encourage or discourage a certain specific behavior for a certain specific goal, which I'll give you an example in a second. But to do this thing, we have this thing called SQL cop, where basically every time you build, everything in HubSpot is Java mostly. And so every time they do a build, there's a build plugin that does query linting. And so adding new lint rules is pretty easy for us to do. So if you want to like ban a feature, or we want to ban foreign keys, we want to ban like some weird thing, it takes like maybe 10 minutes to add a new rule, and then it goes out to every single query. And what we can also do is like we have this plugin collects the list of all the queries that we have and all the schemas that we have, so we can sort of run the lint rules against everything already and be like, okay, well, actually 10% of the organization's using this feature, so maybe it's going to be difficult to ban this feature, or maybe you know, maybe those, I don't know, maybe something. I lost that train of thought. But so here's an example of what this looks like. So there's a smug jerk over there called Sir Jester. This is not related to our linting stuff, but you know, you get like a little thing, and it's like, oh, your build failed, and here's the module that failed, and then here's the query, and here's the thing that we don't want you to do, right? We don't want you to execute update statements in the migrations because, I don't know, use a job to do that instead. You know, a bunch of other examples are like, oh, you know, it could be something more simple. Like it could be like, oh, your query always needs an order by, and this matters because when we're going to upgrade to MySQL 8, the way that, you know, no order by is going to change, and it's going to break all the stuff, so we can like add a SQL cop rule and then just give it like, I don't know, a couple of weeks for everyone to like go through and rebuild and change their stuff, so that by the time we get to doing an upgrade, we don't have to worry about it anymore. Okay, so what didn't work? White glove service. So this was basically some big and important database is having a problem, right? And it's in an especially egregious sort of way. So we allocate a chunk of time and resources to work with the team. You know, we discuss issues, we form a Slack channel. It's a little bit like an embed. So what worked here was that, you know, we ended up understanding teams' largest problems and sort of empathizing with their constraints of what they can and can't do. But it's just like so much work to do this. And there's always like a brand new critical service that's born every single week, and it doesn't necessarily scale. So, you know, I feel like this maybe has its place. Okay, so finally, on to the good stuff. What did work was isolation. So full-ish database isolation between microservices, like we really mean this. Like we try to, and we don't explicitly ban database sharing, but we really, really try to make sure that if you have a service, it has its own database. You don't have these like gigantic databases where 18 different services are talking to this one database, and then that database has one small issue, and then you have this gigantic product-wide outage, right? So we actively encourage teams to split databases, and Vitess actually has a feature called Move Tables, so you can actually seamlessly move one table from one key space to another one, and we make it really easy for teams to make their new databases and key spaces, and then you can kind of like move stuff around fairly flexibly in a way that makes keeping big databases small easy. So yeah. The other thing that we're like kind of working on right now is like sort of within database isolation, right? So we're trying to sort of patch Vitess to add like sort of QoS and load shedding. So for example, we have stuff in the apps where you know that a tag, like an app is tagged with like a bulk job or a critical user query path, right? And so if we pipe those things through to Vitess, then if we have, let's say, stuff starts getting busy in queuing, we can drop all the bulk job stuff that doesn't need to happen in a time-sensitive way, and the user queries can go through. So this stuff works really, really well. Like we've reaped so many benefits of having small databases that it's just sort of crazy. Like if I were to pick one single thing, it's like engaging in this project would be it. But then there's also all the tooling that we build. So finally we get to some of the stuff where how like some of these things actually work at HubSpot today. Right, so this is our key space creation UI. Right, so you have a key space name. You can pick if it's like sort of sensitive or not. Who owns this key space? Is it EU or North America only? How many shards in each place? You hit create. It takes about 5 minutes maybe, and then you have a new key space. Right? No approvals, no waiting, none of this. So are we worried about proliferation is a question that comes up. And the answer is no, right? We start really tiny. So all these things, like I said, are bin packed in Kubernetes. So if you are starting a small key space, that's really like a gap filler, right? We have all these like big key spaces and big things running on these nodes, and there's like all these little empty gaps. And honestly, like when you make a new one of these, that's where that's going. So costs us pretty much nothing. We also allow users to scale up. Right there, it's grayed out. I don't know why it's grayed out. Maybe it's because it's large, but we allow users to scale up themselves. And then they can delete the key space themselves and do all this stuff. So what we get out of this is a reduction in toil, right? Every week there's a new product and a new key space and a new bunch of stuff born, and we just cannot keep up with this. And we don't want people stashing irrelevant stuff into existing databases just because it's easier to do. We want to make it as easy to make a new key space and throw your new table in there than to like glom all your stuff into the existing stuff and you have a slowly growing like big bulk of important stuff in one place. So yeah, what they get is that, as a product developer, trying out an idea is free, right? No permission, no approval, no bureaucracy. And hey, if it doesn't work out, go delete it, no problem. So this is what the sort of like key space UI looks like. I'll go through a little bit of these. So you have a little thing that shows you all the table schemas, and we have table statuses, so you can see the table sizes and the index sizes and all this stuff. And then we have a bunch of dashboards, and I'll talk about all these tools. Okay, so this is one of the oldest things that we built back in the day. So this is the slow query UI, where basically we collect all the slow queries coming up, and they show up, grouped by fingerprints, and kind of like sort this little table thingy. And this is kind of like the detail view where you have the keys view of the query up here. You have sort of, if you hit here, you get the explain format equals JSON. I'll show you a little bit of that. And then you get these little tips where it says, oh, your query is scanning like this many rows. Like you're not using an index. You're using an index. It's doing this type of scan or that type of scan. So there's like some tips there. And then you can hit a button to go to the log UI to fetch like every single like time that this happened if you need to go into detail for some reason. And this is like sort of when these things happened over time and where these things happened, like which app and what called that app. So these are really useful for developers when they're trying to debug where the bad stuff is coming from, right? Because there's a lot of stuff. So we're figuring out where the bad stuff is coming from is like a recurring problem. So we're not adding more to this. It served us well, but we've built another thing that I'm going to show you in a second that we think works better. But yeah, so on here, if you hit the explain thing, you go to this little page where you get a explain format equals JSON, and you get the schema here. So this is really nice. If people have trouble with the query, they just send this page to me and not their query, because it's always like, well, you sent me your query, but what's your schema? Do you have indexes? What's the type on this field? Like, it's always all of these things that you have to be asking people constantly. And now they can hit like create short link and send that over in their support request, and now I can look at that, and all the information that I need is already there, right? So in the future, like Vitess also has like sort of its own query layer, and there needs to be query planning that happens there. So we can add all the VT explain stuff in there too. And it's like, oh, this query is a scatter query, for example, is a thing that causes problems. So we can kind of like do all that stuff in here too. So okay, here's what we're trying to do instead. So this is basically a performance schema, right? So all these things are individual queries, and so for a certain time period, you can see this query executing over time, and a lot of these, like, sort of how many rows is it examining, how many rows is it writing, like all this stuff. You can click and filter by only one single query. You can hit that view callers thing, which will take you and figure out a way to match this query fingerprint to your log, so you can find all the queries in your slow log or your general log, for example. And then there's the little explain thingy too. So this looks a lot like PMM. I think if you use PMM, that's probably pretty great. We might end up using PMM. It's really just a matter of, like, we can really control what this looks like. And like, most of our product engineers don't know what a redo log is, or an undo log is, or what a checkpoint age is. And it's like, PMM is just like chock full of all this junk that when people look at it, they're like, hell no, and they close the tab and go away, right? And so like, there's probably a way to get PMM to like have a custom view of it or something. Like, we use Grafana already. So for us, it was easy to just pipe this in here and call it a day, but maybe in a world, there's a world where we do that, right? And similarly, like, we have regular sort of, this is our cluster health dashboard. We try to integrate multiple layers of stuff, right? So this one chart has cube stuff, right? Like CPU metrics, memory metrics, MySQL stuff, Vitess stuff, and client and app stuff all in one dash. And we like sort of auto link and deep link into different tools. And like, we have all these like sort of explanations where people can look at a metric and sort of figure out how to interpret that metric while they're looking at it, which is good, because I think a lot of times what happens is that developers are looking at a chart, but they don't know if this is it good, is it bad, what does this mean, is a thing that comes up fairly often. So okay, I'm not going to talk about this because I feel like we don't have that much time. Okay, so here is our log fetching UI, right? So this is a little bit like Splunk. It's built on top of Athena, and it has sort of deep integration with our apps in a lot of ways. And it's like you have to plug in or do you want the general log? Which key spaces do you want? You want to do a regex search? Do you want to look at a specific function that's creating a specific query? That's what down method is. And stuff like this. And then you can do some fancy stuff where if you like, you can group by time or group by count and stuff like this, and you can see sort of overtime charts generated from the logs themselves, as opposed to like the previous dashboard where this was from performance schema. So there's like slight differences between why you might want one versus the other, and it's about which information is available where, and we're working on that. We wish it was all available in one place. So what really did work though is libraries and standardization, right? So we also control the client layer of all the database stuff fairly strongly, and there's a good reason for this. Like, it's sort of like a quid pro quo where like, for developers, we give them sort of like the lowest path of resistance, make it really easy to do the right thing, right? And for us, it's a land grab on sort of the area where we need the most consistency. Like, let's say we're doing a MySQL upgrade. Well, like, if everything is consistently using the same type of protocol and the same sort of way of configuring things, then it's a lot easier for us to make organization-wide changes only in that one place where we have to make those changes, right? Or if we need some sort of behavior, right, maybe we got to like add some sort of guardrail or ban some sort of thing, that's a great place to be able to do that if you control that and if that's consistently applied across the entire company. So this is how application developers make queries, right? So they have a little interface thing, and here you have your SQL query, and then over around here you have sort of like these parameters, and then you sort of bind these parameters to things that are arguments to your function, right? So here you have a username, and that goes into the thingy in the query called username. So if you call this function, you get this thing. So now you might notice that here is a thing that's like a complex class. So we have this stuff that looks at the fields of that class and figures out each one of the fields are called and then like plugs the things in the right places and everything. So if you're a developer and you need to create a new query, right, it takes about 2 minutes. Yeah, so and the class itself you kind of define like this, where you're like only write the sort of, this is the field name that I want, and it kind of figures out like, well, there's a get username, so it's going to write a set username too, and it's going to add all these things in there. That happens through code generation. And you have to bind this, but that doesn't matter. And then the SQL migration stuff is like just regular old bog standard SQL that you plop in there. And so then you get this like migration UI. So when your build completes, you go to this migration thing, and in this UI, you get like a list of change sets that your latest build introduced, I guess. And so there you can like click a button and click migrate, and you see sort of this like progress bar of like when it's happening, and when it all completes, you can get a little button here that says cut over. So under the hood, this is all Ghost. We also have a lot of other ways to run migrations. Back in the day, we used to use PT Online Schema Change until we had a lot of trouble with it. You can run direct migrations. In fact, like if we're doing something simple like a create table, we have some smart logic to like parse the change that you're making and figure out the right way to run the migration so that the developer doesn't have to. So what we get out of this is that like complex operations, like a primary key swap, are sort of automatically generated, right? So these tricky things we wrap around. So what this means is that like basically migrations are run safely, and we don't ever have to like look at these things in terms of like whether it's going to be safe to run a migration on an existing database, right? We can have a migration running and queries happening, and like things will sort of adjust themselves. Okay, so then unit testing, right? So you can write database unit tests as long as you inherit this like DAO test-based thing. And what this means is you're sort of creating an object, and then here you're calling the insert function, and it's inserting something, and we have this like sort of silly test that everything works. So what this does behind the scene is that it spins up a MySQL and a Vitesse, and then it applies all the migrations so you have the correct schema, and then it executes this code as if it would. So this helps us a lot because when we're doing upgrades, for example, we can upgrade the Vitesse and the MySQL that the unit tests are running first. And then we deploy that across the organization so we can see if the new version of Vitesse is going to work with every single build and every single repository in the company. So all this junk, it gets a lot of work to do all this stuff. So how does this help us? Well, we can really sort of tailor and improve usage patterns based on this stuff, right? So like adding stuff like, okay, we want circuit breakers, we want like proper enforced timeouts, and all this stuff can happen in the library layer, right? Guardrails for stuff like, oh, we want to check that you have a big int in your database, but an int in your function, and so your Java code is going to explode once you hit that int limit. Like we can check for stuff like that. Like the size of your in list, you shouldn't probably be putting 10,000 things in your in list. Your result set size is too big, right? We can check all that stuff. Yeah, so like we get all these sort of like nice benefits, and there's also like for debugging performance issues, there's a lot of great stuff. So we can get sort of live client metrics and telemetry about how long queries and transactions are taking on individual apps, which is sort of different than measuring things on the server, because sometimes you have problems on the app, but not on the server. Like you have a transaction that's open and there's an external database call and the transaction takes forever, and so your app is having trouble. Like this is stuff where like client metrics help a lot. And then other bonuses, right, like strong authentication, multi-region, like all this stuff we kind of stuff in there. So just by having control of this one extra thing, we get this like sort of massive suite of benefits, and then developers get the benefit of doing all this stuff just because they wrote those 5 lines of code. And especially like this stuff, we try to make it good enough so that developers can look at the stuff and they can figure out their problems on their own so that we don't have to. The other thing that we do a lot is sort of like mass fixes, right? Like our old school of thought used to be, well, like we got to make like some large organizational change, let the teams do it, right? It splits up the work nicely. You have 1,500 repositories and 500 teams, so everyone fixed 3 repositories, and it's great, right? But what we actually found was that teams end up re-encountering the same problems and issues over and over, right? So even when you document stuff, there's like the support overhead of, well, have you looked at the documentation? Have you done this? Like, have you made sure? And there's a sort of a burden to be chasing down stragglers. Like whatever you're doing, there's always going to be like a bunch of different special situations that the main thing that you have doesn't apply to. And so the sort of thing that we ended up changing to was that we want sort of like an efficient division of resources for a design process. So what I mean by that is that like we do the bits that we're really good at, and they do the bits that they're really good at. So like some of the stuff that we don't know about where it's like, oh, how are you using this library? How are you using these queries? Like we can't ever know those things. So we kind of leave that stuff to our own, but we like try to auto do as much of the stuff that we can. And we've built up some stuff for this, right? So I don't know. Oh, okay. My speaker notes disappeared for a second. Okay, so for example, we had to update some of our client libraries, and there was a huge list of breaking API changes. So we did this thing where we have a thing called Mothership where you can sort of like create new branches at every repository at Hubspot. So when you create a new branch, it kicks off a build and unit test and our CI stuff, including the database unit test, right? And then you can sort of track the build errors via the centralized UI of like what used to be failing and is still failing, or what didn't used to be failing and is now failing, and all this stuff. So when your changes are ready, right, you can sort of mass send a PR, click a button, send PRs to everywhere. And so, for example, in this case, we use this thing called refactory, like open rewrite, where it's a thing where you can look at some Java code and write some code to change some code, if that makes sense. So this is how we migrated like a major version upgrade by sort of mostly changing every single team's code so that they didn't have to. Vitesse upgrade, yeah, like we sort of, I don't know if I have time to talk about this, but we mostly did sort of the upgrade seamlessly to most teams, where we like did all this stuff where you sort of do the upgrade under the hood. Jean-François's talk has more details about how this actually worked, but teams mostly did nothing. Some teams had to change a few queries, and that was really it. Okay, I'm gonna skip all this. So another thing that worked is like sort of reaching out early and often, right? Like so there's all these cases where like, you know, everything is great, and sort of they're like, like there are cases where things can be great, or you have some slow queries, and these are mostly okay. But there are sort of situations where you have chronic problems where like you're mostly okay, but like growing so fast that you're going to soon have a problem, or maybe you're seeing some early signs of trouble, and then at the very end we have like sort of everything's exploding all at once. So a lot of times what happens that's sort of bad is that everything is great, and then boom, there's like massive trouble, right? So the question is like, how do we avoid this situation? And like the thing is, like you probably have a thing here where when everything's terrible, you let know the team or yourself, but like sort of stuff might be missing over here where you could have maybe caught a problem earlier and sent it over to the team beforehand, right? So this is how a page looked like for us. So this is every time someone gets a page, there's a little Slack thread that appears. So here we have a link to the query report on the top. So you click and view currently running queries to see why this problem might be happening. So here an engineer was looking at a chart and they were like, what are we doing selecting so many rows? And then they were like, we were querying for blah, blah, blah. And then they were able to fix the problem. Right? So this is, every time I see this is like cha-ching, like I didn't have to wake up. They figured out that they had a problem. They fixed their own problem. This is amazing. So just the savings from like how much time is saved from just not having to deal with this and the developers starving themselves is like worth all the cost of like how long it took to build this thing. Like Yeah, more of this stuff. Okay, and then there's also like this sort of like weekly review thing that we have where like every week teams look at all the stuff that happened that week and they sort of decide whether they're going to do something about it or not, right? So this looks like they had got paged previously and in the Slack thread they had a conversation about what might be going on, and then they reviewed this thing, they assigned it to someone, they said this was a good error. Sometimes things are noise, so they can mark it as noise, and we can be like, maybe we've got to fix the way that we're doing our alerting and stuff like that. But this is how we get teams to systematically work on reliability things on a regular basis as opposed to only when things break. So this is like new stuff that we're trying out where like this is a thing that says, oh, it looks like your queries have doubled from the last week to this week, right? So if you keep going at this rate, you're probably going to hit your capacity limits very soon. So maybe you should look at your query report to see what are the queries and what are the apps that are causing this growth. You should do something about this, right? So this is basically preventing a problem that would have happened in a month or something like that. We have stuff for this for example, replica lag is another one where like, maybe teams are writing a lot and they don't necessarily know about it. And then we have these things that are more, I don't know why these specifically go to Jira, but that's what the organization decided. So these are things that are more of a demand than a request, and it's enforced by the organization. So this is like your key space is 500 gigs and you got to do something about this, right? It's either like you got to delete some data or you got to like split your shard into 2 shards, but we want to keep these individual MySQL instances small enough so that we can like back up and restore those like really fast whenever we have a crisis situation or something like that. So now you have like 2 months or 1 month to deal with this. So sort of what might happen in the future. Oh gosh. Yeah, like some of the things, I'm not going to talk about that one, but like one of the things is like, so why are we dealing with these problems after they've happened and we have all these schemas and queries that are a mess? Well, maybe we should be inducing the well-indexedness from the start. So this is sort of going all the way back to the model where everything is going through a central DBA team, except what we're trying to do is we're trying to sort of carve out a simple enough part of that and saying, okay, well, we can actually look at a PR and look at the new queries and code that's being introduced in that PR, and we can say, is there already an index for this? Because we already keep track of all the schemas and we know what indexes you have, and we can say, hey, you should definitely add an index for this thing. So we're like working our way all the way back to when the bad thing was incepted. Yeah, so we also send people in their ops review slow queries. This is like universally hated because there's so many slow queries always, and rarely are they, a lot of time it's like long tail issues and stuff like that. So what we want to try to do is sort of figure out a way to make these things actionable, right? So we're gonna maybe only send you things if there was a brief spike and during that spike you had like, this query was using 90% of all the CPU resources, then maybe this is really important. And this is way more important than the one query where you're doing it 30,000 times a second, but only 20 of them this week are slow. Like normally, developers get a thing where it's like this query is slow, but it doesn't tell you that it's like the 99.999th percentile, right? Versus here, we're really making people work on the stuff that's actually going to make an impact on their capacity and in their performance. Yeah, we add some fanciness here, but let's not talk about that. Okay, so how do we get people to adopt desirable behaviors, right? Like make it easy and pleasurable to do the things the right way, right? Guardrails, make it hard to do the wrong thing. I mean, when I put it this way, it sounds very trite, but it is what it is. So if you want people to be considering and thinking about something, like you can't just say that maybe they should think about doing that. You need to sort of do something to put that on top of their mind. But if you do it in a way that's really spammy, then people are going to get annoyed. And it's going to be a little bit like the boy who cries wolf, where it's like, we're going to keep sending you slow queries and you're going to fix them and nothing's going to happen. Then that's not really good either. So you want to make them like sort of actionable and significant. Finally, yeah, sometimes doing the work yourself makes a lot of sense. So overall, there's like huge spillover benefits from helping developers help themselves, including more time to help yourself, right? So we can build a bunch of this stuff now because we have so much time, because we don't have to deal with product teams like having problems, because we've built the stuff that deals with product teams having problems. So the small print is that like, this is a lot of work, right? We didn't get here overnight. This took years to get to this point. And we sort of lean constantly on tools that other infra teams have built, right? So this is not, we're not just sort of like magically creating all these like internal tools. It's like the frameworks are there, the lower level stuff is there, and we're kind of like patching them together to get to something useful. So I really want to acknowledge that like a lot of this only works because we have like our company has a lot of investment in infrastructure in a way that cross leverages. And investment means like actual hard cash and developers hired, and not just like we think infrastructure is great and just do more things with the same number of people that you have. The other thing is sort of organizational buy-in on like how important this stuff is, right? So in 2019, we had this, well, I'll talk about this in a second. But anyway, if this stuff wasn't there, it would be pretty difficult for us to do all this. So I'm just saying that like we can only do this because we're lucky enough to have this stuff. Okay, yeah, so in 2019, we have this like gigantic sort of explosion. Actually, you know what, this is not even important. Yeah, so very final slide is that if you want to ever try any of this, like the top tip is to sort of take an expansive view of your domain, right? Like what belongs to you versus not. Like sometimes expanding your domain a little bit could be a little bit more work, but could have a lot more spillover benefits that you might expect. Like once you control that area, you can do a lot of things with it maybe. Starting with core building blocks, right? You want to start with things that have repeat value, right? For the longest time, who owns what database was a thing that we were missing. It's just like it was sort of known in a wiki page somewhere, right? It was like whoever had access to it, but we couldn't really know which Slack channel to send messages to, which engineer to contact, right? Like, and you have those things programmatically, then it's great. And so then, then you start adding stuff where users can help themselves, so you have more time. And then you start carving out responsibilities fully so that you can hand that responsibility to a developer and say, hey, now I'm not going to get paid for this, and you are now going to get paid for this. And here's the runbook on how to deal with it, and here's what you do, and like here's the charts that you look at, and here's all this stuff, right? So you've kind of prepared that whole batch of things that you can kind of like pass it on. Yeah, that's mostly it. Sorry, that was a lot. But yeah.